Role of chemical admixtures in enhancing fresh and hardened concrete properties. Present by myself, Harita R, Manimegle and Nindu. Guided by our internal professor Mr. S. Bhaskar, our external guide is Mr. G. Sivkumar. We belong to Welltech College. Construction industry is experiencing a major development with a tremendous growth. Thus, modern concrete are widely used which possess additives. Chemical admixtures act effectively in improving the properties of concrete, including the strength and durability. The chemical admixtures used in this experimental study is SNF, which is a superplasticizer type of admixture. M40 is the mix design in this study. Along with OPC binder manufactures sand and coarse aggregates of 20 mm and 12.5 mm. The strength test and the RCPT test were conducted. The main objective of this study is to enhance the strength and durability of concrete and also to enhance the workability of concrete. The need for the study. Admixtures of different types are commonly used nowadays to enhance various concrete properties. Thus, this study focuses on the SNF, which is a superplasticizer type of chemical admixture, which is also a second generation type of admixture and is very economical. This admixture serves to improve the fresh and hardened concrete property. SNF is highly pure and it makes the cement particles with high dispersency, low foaming, high range water reducing and obviously strengthening. It also improves cement workability and mobility. The main advantages of SNF are it can adapt to various cements as well as non-erodent and it's non-poisonous. It can be applied to highway, hydroelectric project, boats, quay and skyscrapers, etc. The properties. The properties of the fresh and hardened concrete are as shown. Admixtures. Types of admixture. The main classification of admixture is that it's chemical and mineral admixtures. We have further classified into accelerating, retarding, water reducing, air entraining, superplasticizing, and thus for mineral admixture it is further classified into fly ash, blast furnace slag, silica fume, rise as ash, etc. Superplasticizers can greatly enhance concrete performance. It can give high strength, durability, low shrinkage and safer placement. The properties and nature of SNF is as shown. It's made using naphthalene, formaldehyde and sulfuric acid. It works well for concretes up to 60 megapascal. It has better initial slump than lignosulfates. The long retention of slump is possible. The methodology followed for this experimental study is shown. The codal provisions used for this study are as listed, which includes the IS codes and ASTM codes. Review of literature. These are the literature studies that were carried out, which includes the papers of various authors. The test methods. The test methods conducted for fresh concrete are tests for workability, air content and bleeding, whereas for hardened concrete are tests for compressive strength and flexural strength, etc. The raw materials data is shown in the tabulation. The materials along with the quantity used is tabulated. The workability test was carried out to find the optimum dosage value for the SNF to be used. Thus, from the values, an optimum dosage of 0.8% of cement content which gives a very high slump, that is very high workability, is chosen for this experimentation. The slump cone test results is shown in the graph. The admixture used is superplasticizer SP123 3 at 0.8%. Sieve analysis was carried. The sieve analysis for aggregates of 20 mm size and 12.5 mm size is shown in the tabulation. The specific gravity test which was carried out, the materials used and its specific gravity values are shown. The air conditioning test which was carried out to find out the air content in the concrete mix was done for both the control mix and mix with admixture, and its values are shown. The slump cone test, that is the workability test carried out for control mix, is 110 mm, and thus the value obtained for mix with admixture is 200 mm. Bleeding test, which gives a 2.1% value for the bleeding water. The compressive strength test was carried out for various ages for both the control mix and the mix with admixture. Thus, from this tabulation, we can see the comparison, which shows that mix with admixture shows a high value. The pictures taken during the experimentation is shown. The compressive strength test results is shown in the graph. Thus, here we can compare the control mix and the mix with admixture. The admixtured mix gives a high strength compared to the control mix, which is without admixture. Flexural strength test, which was carried out to find out the tensile strength at the age of 28th day for the both control mix and mix with admixture. Thus, the mix with admixture gives a higher value compared to the control mix. The pictures taken during the experimentation. The flexural strength test results are shown. Thus, the flexural strength value for the mix with admixture is higher compared to the control mix. The durability test which is carried out is rapid chloride penetration test. It is the most suitable test for Chennai conditions. It shows the ages and the values obtained for the various ages. Control mix, mix with admixture at the 31 days. The pictures taken during the experimentation are shown. Thus, from the value obtained, our value falls between the range 2000 to 4000, which is moderate. The test results for mix with admixture are tabulated. Thus, the values obtained for the compressive, flexural and RCPT tests are higher for mix with admixture compared to the control. Thus, we conclude that superplasticizers are able to enhance the placing characteristics by increasing the workability at a given water cement ratio. Therefore, they allow making easy placement of concrete mixes even with low water cement ratio as required by strength and durability reasons. The main drawback is its slump loss. This can reduce or cancel the advantage of using superplasticizers, particularly in very hot weathers. The above listed are the references used during this experimental study, which includes the ASTM codes, IS codes, etc. Thank you.